Okay, so let's get started. We're going to be taking a look at setting up our shift cut feature for an H-pattern dog box transmission and a strain gauge within our Link G5 and G4X programming. Now, this tutorial is going to be taking a look at the basics to get this feature working. We will have an advanced look at bringing in some of our other programming capabilities in the next tutorial specific for an H-pattern and a strain gauge shifter. So let's jump in here and take a look at what we have for programming and talk about setting up our strain gauge first. It's actually pretty simple. And then we'll talk about actually setting up and working with our shift cut. There's some specific things we need to know in order to set up something like our cut times and how much we want our cut percent to be, as well as our ignition retard, and then bringing back in the power using our torque reintroduction. So very specific settings here for working with this so we have smooth and reliable gear shifts and that we don't break the dogs and or anything else in the powertrain, drivetrain as we're working with this. So we're going to move here from our fuel page, and then we're going to jump over here into our page labeled gear cut. So let's go ahead and click on that. Then we're going to find here we have our gear shift control. We want to turn our start shift mode from off, and we want to go ahead and select what we want to work with in this particular window. In this case, it's going to be our gear lever force H pattern. So an H pattern is an H pattern shifted transmission. So this is traditional shifter that's going to be, you shift through a row of the gears. Sequential would be just a lever that's going to be moved up or down to initiate the gear shift. Gear barrel position, a little bit different, typically always found on a sequential transmission. Some of that strategy is different than a typical lever that we pull on in terms of a gear lever force or shift force. And then we have our digital paddle shift, which again is a completely different topic, controlling a sequential transmission with the digital paddle shift option. So we're focusing here on our gear lever force in this tutorial. We're going to go ahead and click OK. Now, when we turn this on, there's a lot of things that come up on screen. It may look really intimidating. It's actually super easy once we break this down and see how this actually functions and works. The very first thing we want to do here is go into our gear lever force and set up our strain gauge. Now, the strain gauge is going to be bonded to your shift lever. You may also have a shift knob that has a strain gauge built in. What this is going to do is translate as we pull the shifter either forward or backwards to make the gear shift. It's going to be sending some type of a voltage output proportional to the force that we place on the shifter. So in this case, we need to configure our source as an analog input. It's a typically 0 to 5 volt sensor output from the strain gauge. And then we need to configure our gradient, offset, and shift force so that the link understands how much force we're putting into the shifter, and then at what point we want to count that force to initiate a shift. The whole purpose of using a strain gauge is that we can do clutchless upshifts on an H-pattern dog box transmission. So we don't want to have to clutch in to make that shift happen. Now, we typically do clutch when we're doing downshifts, but the upshifts can be done clutchless. So let's take a look at setting up our strain gauge, our gear lever force. This link's going to be calling this. I'm going to go here to source, and in my case, I've wired my strain gauge, so it's a 0 to 5 volt output. I've wired that to analog voltage 3. So that's the first step, is to pointing it towards the analog voltage 3. That's again, the input that I'm working with. Now there's an air low and an air high. Because the circuit is 0 to 5 volt, I am going to set my low to 0 and my high to 5 volt. I want it to be able to go the full voltage range depending on my shift force that I'm putting into the gear lever. So I'm going to set this to 0 to 5 volt. Essentially, it's bypassing and disabling any air detection on the circuit, but that's okay because we could potentially hit the min and max voltage ranges of that shifter depending on how hard we're pulling on it. Now, the next thing we want to do here is just jump up into our runtime window. This is our live data. I want to go here and right click, and I'm going to go to properties and change my analog voltage input. Right here, I have it set to analog voltage 4, which is assigned to a trim pot input. I actually want to take a look at the raw voltage that's coming in on my analog input 3, so I can see what's going on with the strain gauge, which is going to give me a little bit better idea setting up the gradient and offset and shift force value. So I'm going to go here. Let's go ahead and delete analog voltage 4. Let's click X, and then we'll type in here analog 3. Let's give that a second. And we're going to grab analog volt 3 gear lever force as our option right here. Let's go transfer that and click OK. Now we can see here, I am not touching the shifter assembly, and I have the strain gauge bonded to the shift lever here on my vehicle. We're going to find that I have my gear lever force reading at approximately 2.5 volt. That's the neutral volt. That's pretty normal for a typical strain gauge, whether it's a shift knob or bond to the shift lever. You'll find that that is going to be what the gear lever force is going to read when you're not touching it. Now, if I go ahead and I just put my hand on the actual gear, on the actual lever, I should say, we can see here it is going to be moving it. So just touching it a little bit, notice what's happening here. We're going to see it's going to read voltage up or down, depending if I'm pushing that lever up or down, it's going to change that voltage. So coming off the shifter right now, we can see it's back to that neutral voltage. So whatever the gear lever force reads when we're not touching it, that's what we're going to put here for the offset. So the offset set at 2.5 volt, and that's exactly what we're seeing here on the gear lever force. So we want the offset to match. Almost always it'll be 2.5 volt, but you may find, again, it might be something like 2.4, it might be something like 2.8, whatever it reads when you're not touching it, that's going to be what you place here for your offset. The next thing here is going to be the gradient. This is going to transmit or translate how much gear lever force in Newton into a voltage scale. So it's going to translate that back here to the link. So this gear lever force will register the certain amount of voltage to a gear lever gear lever force value. So it's essentially doing a translation for us. So this is the gradient, how many volt per Newton of force we're putting in here. Negative 100 right now, we can see the gear lever force. If I go ahead and I pull the gear towards me, that's going to show a positive value. If I go ahead and push the gear away from me, going towards the dash, that's going to give a negative value. Now we can swap this so that it's going to be either a positive or negative depending on how we set our gear lever force here. So what I'm going to do here for the gradient, I could change it from a negative to a positive. So in here I can go from negative 100 so that when I'm pushing it going towards the dash, it's going to be a positive value. When I'm pulling it towards me, it's going to be a negative value. We just got to flip-flop this. Instead of negative 100, we can put it at 100 here. And now if I do the same test again, if I go ahead and I push it towards the dash, we can see it's going to go ahead and be positive. And then if I pull it towards me, it's going to be negative. It's really up to you what you want to set this at. It doesn't really matter, but I'd like to go ahead and typically set it that way. So I'm seeing positive force when I'm pushing it and then negative force when I'm pulling it. The next thing or the last thing we have here is the shift force. Now, actually I want to go back here to the gradient. The gradient is currently set here at 100 Newton per volt. So every time we have a voltage increase, that will increase the Newton gear lever force by 100. This is pretty normal for a gradient that we can use. It really honestly doesn't matter that much, this gradient number. We just need to give it some type of a scale. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.